Hello everyone, I'm Jason. Welcome back to my channel. In the last video, we talked about the Try-Catch IIFE, and a few of you have complained how ugly and unreadable it looks. You know what? I totally get it. IIFE is a bit of an acquired taste, but once you get used to it, it unlocks some superpower far beyond just error handling. Today, I have a mission to make you fall in love with IIFE, or to hate it even more. We're going to look at these 7 modern use cases of IIFE. In case you're not familiar with IIFE, here's a quick refresher. Immediately Invoked Function Expression, IIFE, is just a function that runs immediately. In the old days, IIFE was essential to mitigate some problems with var, but ever since the introduction of block scope variable like let and const, IIFE has started to be forgotten. Don't worry, I'm not giving you the whole JavaScript history lesson in this video. If you're curious, you can check out the companion article that I've put the link in the description box. In the article, I'm going to talk about the problem with var a little bit more in depth and also include all the content in this video. So if you need any quick references after watching this video, you can always refer to the article. Without further ado, let's dive into the 7 modern use cases of IIFE. Oh, actually, before I start, make sure you have subscribed to my YouTube channel so that you do not miss any useful, awesome video like this one. Use case 1. Enable async await. It is not uncommon to call asynchronous function in synchronous code. A classic example would be React's useEffect. If you have ever fetched data in React, you're probably no stranger to this error message. The recommended workaround is to define the async function within your effect and then call it immediately. And guess what a function that is called immediately is? An IIFE. Why even bother naming that function when it is only used once? Naming is well known to be one of the hardest things in programming, if not the hardest. So do yourself a favor, next time, skip the naming and just use IIFE.
Nice.
Use case 2. Const with switch. Sometimes switch statements are used just to initialize variables. Let's take a look at this real example from React. Here are 2 things that I want to point out. 1. The whole point of the switch statement is so that it can initialize the post-task priority variable. 2. Post-task priority is never reassigned afterwards, but we're still forced to use let to declare it because we assign it in the switch statement. We can refactor the code to use IIFE, and all of a sudden we can use const again. What's even better is that we're now returning from the switch statement instead of assigning. We don't even need to worry about accidentally falling through cases. Huge win. So next time when you're forced to use let because of switch, remember, you can always use an IIFE and keep your const.
Nice.
Oh, a quick note. You can actually apply this same pattern with if statements too. Here's a real-world example from Angular. If we turn this into an IIFE, we can even use guard clauses to avoid all the else ifs. Look how much cleaner this is. And since we're assigning to kind immediately, we can even skip the explicit type declaration because TypeScript type inference can figure out what the IIFE will return. Speaking of guard clauses, that leads us to the next use case. Use case 3. Inline. Use case 3. Inline guard clauses. Ternary operators are great, but when you chain multiple of them together, it becomes less readable. Let's take a look at this real example from Vue.js. Quick quiz, can you tell how many conditions were there? It's likely that you have to look through each ternary to figure out that. Now check out the IIFE equivalent. So much cleaner, right? You can instantly see that there are 3 conditions and a default fallback to no op. With IIFE, you can turn those messy chain of ternary operators into just simple guard clauses.
Nice.
Use case 4. Stateful function. From time to time, you might need a function that keeps track of its own state. Consider this simple example. In this version, nextCount is sitting outside of the function getNextCount, meaning that it could be modified somewhere down the line. You could trust your team to not touch it, but can you really? By using IIFE, you're guaranteed that the nextCount variable is only available to your function. Just like that, your counter is fully tucked away from your team and even your future self.
Nice.
So next time when you need a stateful function, just use IIFE and keep those states out of touch from other people. Use case 5. Object property initialization. IIFE can be used to create a more encapsulated object construction pattern. Check out this real example from Angular. This pattern is pretty standard. We do some setup, in this case setting up the tutorial files and finding out the dependencies, and then use the setup in the returned object. But there are two main issues with this pattern. Firstly, this can lead to spaghetti code very easily. I mean, just look at this function. There are only 3 lines of setup, yet the JSON parsing still finds its way in between the declaration and the initialization of the tutorial files. The second problem is that the setup and the property initialization, they are in 2 completely different places. With IIFE, we can group everything related to a particular property in just one area. And with this pattern, I'll be impressed if you manage to find ways to mix up the setup logic. They are in 2 different functions. How are you going to mix things up? So yeah, with this pattern, each property becomes self-contained and everything is perfectly encapsulated. Isn't that great?
Nice.
Use case 6, Try-Catch IIFE. Well, I have talked about Try-Catch IIFE in the previous video. If you still haven't watched my previous video, don't go yet. But remember to go after you finish this video. The last use case is the most important. Use case 7, hierarchy of abstraction. This use case is a little bit more philosophical and it might not click right away. So please bear with me and keep an open mind. Consider this pseudocode example. What do you think the hierarchy of abstraction would be in this example? Well, when I say abstraction, maybe what I meant was the dependencies between things in the code. In this case, get position depends on x and y, and x depends on AB, y depends on CD. So we have 3 levels of dependencies or abstractions or whatever you like to call them. At the top, we have get position. In the second layer, we've got the x and y, and the third layer, we have A, B, C, D. In the current version, everything is flattened in a single scope. Even though there's a semantic hierarchy, there's no visual hierarchy. This means that readers will have to mentally construct the hierarchy themselves, and this takes up quite a bit of cognitive load. Once you have built that mental model, say you're only interested in the higher level of the function, then suddenly A, B, C, D becomes noise. I call these dangling variables because they're just used once and they're dangling within the function scope. Doesn't really do much, just confuse readers. One way to visually establish hierarchy is by extracting functions. This works, but it comes with some trade-offs. Firstly, these functions might be highly specific to get position and would not really make sense when they are outside. Secondly, naming is hard. We've already got the getX and getY function, so what do we call a function that does some setup and return X? getX2? Thirdly, you might need to pass down a lot of dependencies that might lead to argument passing hell, if that's a thing. And the worst of all, readers would now need to jump around different function definitions to understand the full picture of the code. And this is where IIFE shines. It lets us keep everything in line while still providing a clear visual hierarchy. With this pattern, we've created a visual hierarchy that mirrors how we think. Get position needs XY, X and Y has their own little world that does some setup and somehow get X and Y for you. No dangling variables, no unnecessary naming, no jumping around.
Nice.
This pattern is clear, encapsulated, and easy to zoom in and out of the logic without friction. However, with every great solution, there are downsides. And the clear downside of this pattern is that it can become quite syntactically noisy. That is why I only reach out to it when the structural clarity it brings outweighs the cost in readability. I'm not saying you should use it everywhere, but now you have got one more tool in your belt for those moments where structure and clarity really matter. And that's it. These are the 7 modern use cases of IIFE. To recap, use case 1, enable async await. Use case 2, allow you to use const with switch to initialize variables. Use case 3, replace those chained ternary operators with inline guard clauses. Use case 4, stateful functions. Use case 5, object property initializations. Use case 6, Try-Catch IIFE. And finally, use case 7, hierarchy of abstraction, the philosophical one. As we've seen, IIFE isn't a relic from the pre-const and let day. When used well, IIFE gives you structure, clarity, and encapsulation. Of course, it's not something to reach out blindly. It can be a bit noisy, and sometimes plain flat code is the code you need. But when it does fit, it fits beautifully. I hope this video gives you a new lens on how to write cleaner code, or at least a little appreciation for a pattern that doesn't always get the love it deserves. So what do you think about these use cases of IIFE? Have I changed your mind about IIFEs, or do you still hate it? Let me know in the comments. I'd love to know what you think. Thanks for watching. If you enjoyed this video, please hit the like and subscribe button. And don't forget to share this with your developer friends who still use Lab because of Switch. See you next time.
Nice.